Let us take the third factor, which is the temperature. Now temperature, in terms of temperature, we know that the reactions can be of two types, either exothermic or endothermic. Now the exothermic reactions are the reactions in which energy is released. The sign of the enthalpy is negative, whereas the reactions in which the energy is absorbed, called endothermic reactions, the sign of the enthalpy is positive. Now let us take both these cases one by one. Remember, for exothermic reactions, the increase in temperature favors the backward reaction. Therefore, rate of backward reaction gets increased. Let us take the example of, again, this reaction. The reaction which is taking place in Haber's process, in which nitrogen combines with hydrogen to form ammonia. The reaction's enthalpy sign is negative. The negative sign means the forward reaction is exothermic. It means forward reaction is exothermic and backward reaction therefore is endothermic. It means when we are moving, we will be dissociating ammonia to nitrogen and hydrogen, we will be needing energy. So sign will be positive. Now for such a case, if the temperature is increased, it means we are giving energy to the same reaction. It means what? We are favoring the backward reaction, because when the forward reaction energy is released. So that means if the temperature is increased for such an exothermic reaction, we are favoring the backward reaction. So what will happen is the equilibrium will shift towards the backward side. Rate of backward reaction gets increased. So therefore, rate of backward reaction increases and equilibrium shifts to the reactant side if temperature is increased, or if temperature is decreased, it means we are taking out energy from the reaction mixture. It means we are favoring the forward reaction. So what will happen is rate of the forward reaction gets increased. So I can add a word called and vice versa. It means what? For exothermic reaction, if temperature is decreased, rate of forward reaction increases. आगे भागेगा वो, it will increase to move toward the forward side, and equilibrium shifts towards the forward side. This is most important. So this is how we can manipulate the reactions which are exothermic in nature. Now let us take the examples of endothermic reactions. The reactions in which energy is absorbed. Now remember, the increase in the temperature for endothermic reactions favors forward reaction, therefore rate of forward reaction gets increased and equilibrium shifts towards products side, and the decrease in temperature will increase the rate of backward reaction and the equilibrium will shift to the backward or towards reactant side. This is most important. Let us understand this by taking an example. The example is of the thermal decomposition of calcium carbonate. The enthalpy of this reaction is positive. It means this reaction, the forward reaction, is endothermic. Therefore, the backward reaction is exothermic or will be exothermic. So if it is moving in the forward direction, the energy is absorbed. If it is coming back from the product to the reactant side, the reaction is exothermic. Now, if the temperature is increased, in such a case, it means we are favoring the forward reaction. Therefore, rate of forward reaction increases. Whereas if temperature is decreased, we are taking out energy from the same reaction mixture, which is actually requiring energy. It means we are favoring the backward reaction. It means what? The equilibrium will shift back towards the reactants because rate of backward reaction gets increased. So this is how we can easily understand the effect of temperature on equilibrium.